Okay, so today is day 3 of our law of sines notes, and I added in the area part because we're going to be using a very similar equation. Okay, so today we're going to be talking about the area of oblique triangles. Now, right triangles are really easy to find the area of because the height is one of the legs and the base is the other one of the legs. But when you have an oblique triangle and you don't have that 90-degree angle, it makes it a little more difficult. So the area of an oblique triangle, the procedure used to prove law of sines leads to a simple formula for the area of this triangle. Okay, so referring to the triangles below, each of them has a height of h equals b sine of a. Okay, so we're going to be using that height equation that we've been using with the law of sines to find the height of the triangle to actually use it to find the height when we go to find the area. Okay, and it doesn't matter if it's an acute triangle or it's an obtuse triangle, we can use this equation. Okay? So, the area of a triangle for side, angle, side. So if you know two sides and the angle between them, we can use this equation. So remember, the area of a triangle is 1/2 base times height. So on this triangle here, the base is side B, and the height is given by side C times sine A. Now, that equation right there actually comes from our right triangle trig, because if this is our angle right here, then basically sine of theta is, if you remember, opposite over hypotenuse, which means sine of our theta is h over c, and this is, of course, our A, our angle A. And if you solve for h, that means h equals c times the sine of angle A. So this height equation basically comes from SOHCAHTOA that we've done before, our right triangle trig. So that's how we get this height right here. Okay? So it's basically we're just using trig and we're plugging into our triangle, area of a triangle equation that we learned in like 5th grade. Okay? So that leads us to our equations, and this is the area of any triangle, okay, given that you have side angle side case. Okay, now there are 3 equations here depending on which angle they gave you. So if they give you angle A, then you're going to use 1/2 b times c. Okay, you'll use this one if it was angle A. Or you could use this one if they give you angle C, or this one if they give you angle B. It's a really simple equation, really simple process. Okay? So here's an example. Find the area of a triangular lot, two sides lengths 90 meters and 52 meters, and an included angle of 102. Okay, so the fact that they say that the angle is included, that means it's in between my two sides. So the first thing you should do is draw a picture. So if we draw this picture, this is what our triangle looks like. You have a side that's 52, a side that's 90, and then that included angle between them is 102 degrees. And then you're like, oh, I've got angle C, so that's the equation I'm going to use. 1/2 AB sine C. Then you just plug in side A, side B, and angle C. Plug it into your handy dandy calculator, and you get approximately 2,289 square meters. Okay? That's all there is to it. The only added part to this is you might actually have to solve your triangle from one of these. So like if I didn't have side A, or if I didn't have side B and I had side C instead, I might have to do my law of sines to find one more piece of information before I could use this area equation. So sometimes we have to do law of sines in order to do the area one. Okay? But that's just one more step, just added to what we've been doing. Okay?